Okay, and we're back. So, in the first part of class, we saw a Java servlet. We ran that Java servlet inside a web container, and it became a web server, and we were able to exercise that servlet through a couple of different clients. Let's, you know what, I'm going to, just for the sake of demonstration, I'm going to make a couple changes here to the servlet so we can just see what's going on. So I'm going to start up my Jetty again. So it's running. Now, and so I'll exercise it from the command line here. It doesn't have anything, and then do, oops. Fine, I'll just have to repopulate it with some stuff. Doe, a deer, female deer. Ray. Drop. Okay. So now I've got a couple of things, and they're all there in my server, and you can see them, and this is swell. Now I want to make some changes to my web application. Okay, I'm just going to add some logging. So I'm just going to log to system.out. And I'm just going to say adding word definition, to the dictionary. And I'm going to say, I'm going to have that there, and then in write definition, I'm going to say here, I'm going to say system.out.println. The definition, oops, that's weird, of word is definition. And then when I'll just say here, I'll just say system.out.println, writing all dictionaries. Okay. Now, I made these changes to my source code, and if I try to run it again, I don't get any output because, well, I need to recompile it. So in order to recompile it, I need to stop my Jetty server. Luckily, if I run Jetty again, Maven will recompile everything for me, which is nice of it. So it compiled some new stuff, and now when I run it, I get some output. And oops, I just added it twice. And then array. And now if I then output everything, okay, good, I'm seeing more stuff. So when you're working with servlets, because that program stays running the entire time, if you make a change to it, you need to bring it down, and you need to recompile it and bring it back up again. That's, well, this is nice and fast, but in general, that's pretty slow. And it's different from what you were used to probably with your Project 1. Although if you're testing the command line, then you're probably having to do some amount of recompilation. But this still seems a little slow. And if you get a super big web application, it'll take, it could be a number of seconds or even as 2 minutes to turn around. And that stinks, right? Because it slows you down and you want to go fast. Now, when we were developing our command line applications, one of the ways that we went fast is by unit testing. And so, when you had your phone call and your phone bill and stuff, you could do unit testing pretty quickly because the API was pretty simple, right? You were like creating a phone call, you were adding it to a phone bill, you could interrogate it, and stuff like that. It was pretty straightforward. But if you look at the code that you're writing here for the servlet, it has things like do post, which takes an HTTP servlet request and HTTP servlet response. And how do you deal with those things? right? I want to be able to write a unit test that exercises this code. But how do I create one of these HTTP servlet requests? Normally, it's Jetty that provides me with one of those. How am I going to do that? This is where things get interesting in unit testing, and this is where we start to see some way more advanced stuff. So the archetype creates a couple of unit tests, and one of them is called phone bill servlet test. So I have my servlet object, and I want to, it expects to be run inside of Jetty. But as you see, it takes a little while to start up Jetty and interact with it. Well, what if I tricked it into thinking it was being run part of Jetty, right? Because it really only has a couple dependencies on Jetty, namely the HTTP servlet request and the HTTP servlet response. Okay, how can I trick it? Well, an HTTP servlet request, it's an interface. Okay, so let's take a look at it. It's an interface that has all sorts of methods, like get header names and get integer, and well, that's a lot of stuff. As a matter of fact, when the servlet interacts with it, let's take a quick look at see what it does actually with those objects. So here, I'm passed in a request and I pass it through to get parameter, and here, if I look at where my request is used. Oh, I didn't highlight it like I wanted it to. Here I call get parameter. Okay, so really all I'm using from the HTTP request is the get parameter method. So in order to trick my servlet into thinking it has a real HTTP request, all I need to do is give it an HTTP request that when get parameter is invoked, something reasonable is returned. Okay, because wouldn't that be great? You have this servlet object, which is pretty complex, right? And it expects to be run inside a web container, but really it only depends on the web container for a couple of things. So if I can just sort of trick it into thinking that there's a web container there, it'll be happy. Really, all it needs is like a servlet request that returns a reasonable value and get parameter is called. And similarly, when it interacts with the request, when it requests with a response, I think really the only thing it does with the response, it calls getWriter, it calls getSetStatus and stuff like that. And so I want my unit test to verify that it's doing the right thing with the response, but I don't really need to have all of the functionality of a response. So wow, wouldn't it be neat if we could do all of that? Well, you can using an advanced testing technique called mocking. So again, these are the servlet API defines these interfaces like HTTP servlet request and HTTP servlet response that do things. There's a library called Mockito that uses some magic, and it's pretty serious magic, I'm a big fan, to create what are called mock objects that you can teach, you can configure to behave the way you want them to behave, right? So like here's a test that verifies that initially the servlet contains no dictionary entries. And when I'm interacting with my servlet, basically what I want to say is like, listen, I want to invoke my doGet method with a request that has like no parameters associated with it. And when it does that, I expect that what was written to the response contains a message saying, hey, there are no entries in that. That's the behavior that I want to test. And I can do that, and I can get that behavior by using these mock objects. This is wacky. I'm going to walk you through it. It's explained in detail in the dependency injection. Maybe it's I can't remember if it's in the reflection lecture. It's probably in the dependency injection lecture. So that's technically for week after next. If you're comfortable with unit testing, and if you want to explore some advanced stuff, I recommend you go with this. It will blow your mind, but it'll also change the way that you write unit tests. It's super cool. Basically, what this is doing is the Mockito API provides like a method called mock, which says, okay, I need a HTTP servlet request for my doGet method. Well, create me one of those, but create me a mock one. Same thing with a response. And the same thing with, give me a mock print writer. So this is an object that implements a print writer interface, but instead of it being a print writer that's returned by, I don't know what's a class, that is a subclass of the print writer, it provides the same contract as print writer. It is a print writer. Make it magic. And we'll see, and with the magic, you can do things like the following. You can say, okay, hey, I have my mock response right here, and say, hey, when getWriter method is invoked on my mock response, then return this print writer right here that I created right there. Okay. Now, when I call doGet with my mock request and my mock response, actually, we should probably call it that. That would make it a little easier to understand. I'm going to call it mock print writer. Oh, those lines didn't show up as changed. I wonder why that is. Anyway, when I say, hey, call getWriter on my mock response, now getWriter is a method that's specified by the API, right? When that's called, return my mock print writer. I basically configure my objects that way. I send my mock request and my mock response off to my servlet. My servlet doesn't know the difference, right? Because I provide it with an object that implements that interface. It interacts with it just like it would normally. And then after that returns, I say, hey, verify, this is another Mockito thing, that the print line method of my mock print writer was called with this thing. And also verify that the set status method of my mock response was called with scok. And it works. So what you're doing is you're able to test a very complex object like your servlet that has all these crazy APIs that it depends on. You're able to still test it in a unit test, nice and fast to run, right? Didn't need to stop my Jetty and restart it once I changed my code, right? You can have this very fast iterative loop of implementing and debugging like you do normally with any other Java test, but you can do it with your servlet. You can do it without having to make your servlet go through all sorts of gymnastics.
So you might, this is so that it's a pure unit test, whereas you might not use a mock object for an integration test.
Exactly. So, and yeah, we'll see in a little while how the integration tests work. Yeah, very good point. So here's a very simple test. You can also implement more interesting stuff. So here is, let me see the whole thing. Here we verify that when we when the doPost method is called, and again, let's make these mocks. This is with my mock request and my mock response. And then it's probably mock print writer. Yeah, print writer. When I call doPost with my mock request, my mock response, when this particular mock request and mock response, I get a successful definition happening. Here, I teach my mock request to say, hey, listen, when get parameter is called with word, then this test word is returned. Similarly, when it's when the definition is when get parameter is called with the string definition, then my test definition is returned, and then this goes down here and verifies it. This is advanced stuff. I'm not going to spend too much more time dwelling on it, but it's super cool. And it allows you, again, to write unit tests for your servlet that otherwise would be pretty hard to test, or you'd have to go through some acrobatics in the servlet in order to send the information in. Okay, and you can learn more about this in the dependency injection lecture. Any further questions on this? Any other people want to discuss? No? Okay.
Just a quick question. Sorry.
No.
Why tried to verify versus like an assert?
Ah.
You say an assert mock,
You could well, okay. They can't call it assert because assert is a keyword and wouldn't compile. But verify is just the method they choose.
Well,
Here.
I mean, sorry.
Yep.
What does verify do that's different than assert?
It allows you. This is all about having code that test that is supposed to be easy to read. So it's like verify that when the print line method on this object is called. And verify that the print line method has been called with this data, with this argument right here. And that's where the magic is necessary. In order to do all the bookkeeping on this mock object, you need to interact with it this way.
Okay.
Yeah.
So is it just using reflection as well?
Yeah, reflection and bookkeeping and some.
Bookkeeping like a concept similar to reflection?
No, I'm sorry. Bookkeeping. I mean, it keeps track. Okay, yeah. So the way this works underneath covers is that you send your mock request to the doPost method. doPost will call getParameter. Now the implementation of getParameter on this mock object, has some map or something that looks things up, and it's like, oh, okay, when the string word is passed in, then return the value test word from the getParameter method. So that's what by bookkeeping I mean. It's their smarts inside that mock object to know what to return. You can, if you look at the Mockito API, if you study it, there are very powerful things that you can do to program these mock objects. You can say, well, the first time it's called, return that value. The second time it's called, return this other value. So what this allows you to do is sort of like create this test environment where you're passing just the right data into your code under test. It interacts with it like it doesn't know what it's doing, right? Oh, if it's calling this, I'm calling that. It gets exactly the data that you want it to get. It does whatever it does with that data, or returns whatever result, or performs whatever operation. And then you can maybe interacts with other mock objects, like the mock response. And then after your code under test is completed, then you can use verify to say, well, okay, did the code under test interact with this mock object the way I expected? And the way I expected it to interact with the mock print writer was call the print line method with this string right there, and I expected it to interact with the mock response by calling the set status method with that value right there. Yeah.
So the verify, it looks like the verify when it's plumbing for mocking for kind of mocking the servlet, right?
It's the data passed
HTTP.
into the servlet. So the servlet itself is just a servlet, right? Yeah. But what it does is it provides these objects that I think of as bookkeeping. Like it's like, where it's like, oh, okay, I've been told how to. So like when you use when, you're basically telling the mock how to behave. It's like, oh, when somebody interacts with you, behave this way. Oh, return this value.
So use when and verifies to mock whatever you need to test this particular function. So
Yes. So the when tells it how to behave, and verify is where it tells you how it behaved or how it was interacted with. Yeah. Cool stuff. Pretty advanced. I encourage you to play with it. It's neat. Let me check these changes right in real quick. What did I change here? Oh, I just added some. Okay. So added some logging. Oops. No. Commit. And then here renamed some variables. Jeez. Okay. There we go. Push. So far in class, we've explored the servlet. We've seen how to debug it, how to walk through what it does. That's an important thing that I think will help you with your projects. We've seen how to unit test it. We have to unit test in kind of a wacky way using mocks, but it's possible. So if you're a big fan of unit testing or you want to explore it, you definitely can do that way. The servlet is half of your program. Let's take a look at the other half of your program, which is the command line tool. That is here in your Project 4 class. Project 4 contains the command line parsing, so there's really not too much interesting stuff that I want to show here other than, oh, look, we've got a bunch of variables with the information on the command line, the host name, port, word, and definition. We populate all that stuff as we parse the command line. This is the interesting thing. There's something called a phone bill REST client. So let's think about what our Project 4 main class needs to do. It needs to pass the, it needs to parse the command line. Old hat, you guys have been doing that since the first week. But now it needs to interact with the server, and it needs to interact with the server in Java code, right? We saw that, like, the web browser, you hit URLs, you use the HTML forms, and it interacts with the servlet. And we saw that the command line can do that, but we didn't see how it can do that. So Java has a bunch of APIs for interacting, well, for doing networking stuff, and it's all in the Java Net package. And it has many layers of the networking stack, everything from getting a socket and just writing data there. So you've got TCP, it can do UDP. And then it has support for protocols on top of that. And the important protocol that it has is HTTP and HTTPS. Now, as you might imagine, the standard APIs for dealing with something like a URL are kind of low level in places. It really exposes just the bare bones of the HTTP protocol, and you want something that's more interesting than that. And I have provided you guys with some code to handle all of that, and it's used in that phone bill REST client. And we'll dig into that in a minute. But let me show you what the phone bill REST client is first. So you create the client and you give it a host name and a port. And so this is the client that will then make those REST API calls off to your server. Now it reads, it handles the command line. So if the word is null, so if you want to print all of the word definition pairs, it will call get all dictionary entries from the client, which returns a dictionary, the map of string to strings, and then it prints it out. So this is the magic, and we'll look at it in a little bit. This is the method that does all of the communication with the server. Similarly, if you're just looking for a definition for a word, so you've passed the word in on the command line, but you haven't haven't provided a definition, then we'll call the get definition for a word method on the client. Now this is client-side code. We'll see that it's Java, but it's not the thing that it doesn't deal with the dictionary itself. Instead, deals with the server, the servlet, by making an HTTP call. And then finally, if you have both the word and the definition on the command, we call add dictionary entry from the command on the client there, and that'll handle that. Let's walk through it in the debugger to continue to explore what it's like debugging this application. So let's see here. Did I run this? I think I ran this in debugging mode. So I am going to attach to my Jetty server here in the debugger. So now I'm attached to the Jetty server, which is running on the command. And now what I'm going to do, I'm also going to create a new configuration, which I'm going to call remote. And actually, you know what? I'm not going to do this. I'm going to do something else. I am going to run this main method here from IntelliJ. Okay, and this is the output. It says missing command line arguments. Okay, now I'm going to configure how I run this project for. I'm going to give us command line arguments. So the first one is the localhost, and then the port, which is 8080. This is the port that it communicates with the with Jetty on. Okay. So now I'm going to add those arguments there. I'm going to run it again. Oh, there it is. It's got the two words, doe, deer, as doe and ray. I'd forgotten about that. Okay. So now I'm running the command line, and I'm doing that. Now I want to debug things, though. I want to see what's going on. So now I'm going to go over here. This is similar to what this is exactly what we did before. Now here on my get post, I'm going to get rid of that one. I'm going to put a breakpoint back on my doGet method. I'm going to run my client again, and the debugger stops here. Yeah.
We've never talked about how it is persisting on the server side.
Ah.
Is that-
Question about it. How does data persist on the server side? It doesn't. If by persist you mean, by persist you mean persist between requests or persist between invocations of Jetty?
Between requests.
Aha, between, okay. Let's see. Okay, so I'm now, I've attached the debugger to my Jetty. So this code is running inside Jetty. Remember, distributed computing, 2 processes running. So this is running inside my Jetty server. I go and I get the parameter, the word is null, and so we're going to write all the dictionary entries. So I'm running on my server. Remember, my server's been running for a long time. I'm telling it to format dictionary entries from my dictionary. My dictionary is the thing that has the two entries in it. So my servlet has a variable called dictionary that's created when the servlet starts up. When the servlet object is instantiated, it's got an instance field with a dictionary. I'll let you guys think about how you would store your phone bill objects. Yes, that's how it persists in between requests. Now, if I stopped my server, I think we've seen this before, if I stopped the server and started up again, my dictionary's gone because all I do is store it in memory. In the real world, you probably wouldn't do this. You would write out some files, store it in a database, do whatever. But yes, for the purposes of Project 4, just keep everything in memory. Good question. So now I've done all of that. I'm just going to, I'll step through all of this, and then, okay, now I'm done, so let's continue. And now, if I go back to where I'm running, there it is. So this was me running my main, and it printed out dictionary. The server contains 2 words, and the process finished with exit code 0. This is neat. Okay. I want to show you how Project 4 works. So now I'm going to set a breakpoint in Project 4, and I'm going to debug Project 4. So now I'm running Project 4 in the debugger. I'm here on the first line. Well, this is great. Okay, I'm going to step through all of this. Oh my gosh, I'm going to skip over all of this like parsing the command line nonsense. You know all about that. Let's get into the interesting thing right here. Okay, so I'm just going to run to cursor or run to next breakpoint by doing F9. Okay, now I'm here. Okay, so I'm going to create my phone bill REST client. It takes a moment because I got to load some classes. Word is null. Okay, so now I'm going to call client.getAllDictionary entries. Just thinking about it. The debugger stops again. Back in doGet. I'm debugging 2 Java programs at the same time. My single IntelliJ is connected to 2 debugging sessions. One is the debugging session for Jetty that we've been looking at all along, and that's where it stopped right now. But previously, I was also debugging my command line program. Distributed program. 2 Java programs talking to each other over the internet. It's the wave of the future. We're going to have a VRML interface next. You remember VRML? No? Virtual reality, markup language. It was hot for like 20 minutes in like 1999, and then like I see all this like virtuality stuff now, and it's like, oh, it's like the same thing. Anyway, so you've got 2 programs. They're talking to each other. You're debugging each of them. But what you can do now is because you're debugging them, you can sort of stop the world. So I can go back, and so I've got my Project 4 debugging session right here. If I pause it, it'll tell me. Oh, well, actually, yeah. Here's the code that's in. Oops, sorry. Here's the code in main that's invoking. It's still here. It's getting all the dictionary entries, but now it's gone off and made, and we'll see more of this in a second, it's gone and made an HTTP request. It's still waiting off to the server, and now the server has paused here in the debugger waiting for me to step through it. I recommend that you learn how to do this. Yes, it's more complex, but it's a lot easier to work with than adding print lines or trying to guess what's wrong with your program when you've got two processes talking to each other. So I've made that same request again, and I'm just going to do what I've always been doing. There's the word is null, and so now I'll just go back. And now if I go back to project 4, oops, sorry, maybe I didn't, did I F9 here? No, I didn't. Now if I go to project 4, my debugger is stopped on the line after this. So this is where it gets weird, right? It's like you're used to. You start with your main method, and yeah, maybe call other objects and stuff, but it's always within the same process. Well, now it's like, oh, my main method starts doing its thing, and then it calls this other program, which does some stuff, and then it returns, and now this guy returns. Right? More advanced stuff. And now I can step through all of this. And now I get, so now I got what the servlet returned to me, which is the string dictionary, and the server contains 2 words. And there they are. Yep. And now this program is done. My project 4 exits. It's all happy. My Jenny server, on the other hand, is still running, just waiting for the next request. So now if I run this under the debugger again, but let's run it with different command line arguments now. Now let's change how that's run. Oops. Change how it's run, and now let's put in do right here. If I run it again, stops there. I'm just going to get rid of that breakpoint because it's annoying. Now let's continue on where I create my client. Word now is do. I go through different logic here. Now I'm going to call client.getDefinition with the word, which is do. Now when I go to the next thing, it's under the covers making a call off to the server, and now the server debugger session says, now I'm calling the doGet method again. And now I'm calling doGet. The word that's passed in from the parameter is that do, right? So you see how data flows from the client to the server? And now I can just do my thing. I'll write my definition. I'll exit, and I'll be happy. And now back in my project 4, I've executed that. I've written some stuff out here. Oh, maybe I haven't yet. I'm about to, though. There's my message, and I'm all done. I'm showing you all of this because what you're going to do in your assignments is you're going to take the skeleton and you're going to add your stuff to it, right? You're going to change some stuff in the in the project 1 to implement the command line interface that's there in the assignment. Then you're also going to change stuff in the servlet to, instead of serving up this dictionary, serve up phone bills and phone calls. And along the way, you're going to debug stuff, right? Stuff's not going to work. You're going to figure it out. And I recommend that you take the time to sort of figure all of this stuff out because you'll get really good return on that investment. Right? You spend maybe an hour or two sort of like figuring out all this stuff, how to set breakpoints, how to get everybody to talk to each other, but then it'll go way faster. Yeah.
Just so it's in place in the video.
Yeah.
Do you mind breaking this all down and then putting the 2 debug sessions back in, just so we have a spot?
Oh yeah, that would be that. Just send me an email or post something to the community about that. And actually, you don't have a machine in front of you, but could someone then just like, hey, Dave, remember when you said you would do that thing in the video? So what you basically want is a bookmark here to say, hey, go to this part in the video. No.
I'm actually asking you to take the 2 debug sessions down and set up the configurations again such that it's in a single video so we can see
Gotcha.
how to set up one for the
Okay.
front end and one for the back end.
Great. Yes. I'd like someone to make that request of me so I remember to do it. I don't know if I'll be able to do it tonight. I'll try to do it as soon as possible, though. I'll try to get to you before the weekend. Yeah. Yep.
So I guess, is there an expected way from what I read, I didn't really see an expected way for us to do that. Where a dictionary is a one-to-one mapping, but we have a phone bill and we can map like 1,000 different ways. We can have it based on date or number or caller number, caller called number, like you could.
Well, actually, I think there's really only one way that you want to map. I don't want to give away the secret, but I think it'll come to you. Cool. Okay, so let's. So this is the command line interface, and so as we've seen, what the command line interface does is it parses the command line, and then it relies heavily on this phone call REST client object. So let's dive into that. So phone bill REST client is a helper class that wraps a lot of the interaction with the REST API with the HTTP requests and responses. So it does things like puts together the URL, and then various methods it interacts with that URL. And it interacts with that URL using some code that I wrote called HTTP request helper, which does a lot of the heavy lifting. So this is something that I hope helps you sort of do all this heavy lifting more easily. So the way it does this is the following. So the phone bill REST client provides nice abstractions over the REST API. So it has a method called get all dictionary entries. And what does it do? Well, there's a method called get that inherits from HTTP request HTTP request helper that takes a URL, or actually can then optionally take parameters. We'll see examples of that, and performs a get on it. And what it returns is an object called a response. And a response is something that, so it's not the HTTP response that's on the servlet side. It's its own response object that contains things like the content that was returned from the HTTP request as a string, and then you can also get its error code there. So this is my attempt to help you deal with all of the communication with the server, but the price you pay is you got to figure out this API. I don't think it's that bad. So what I do is I call get, and this gives me a response, and then I have this parse dictionary method which goes and creates that dictionary of key value pairs from the content. So let's run this. Let's see here. Let's run this under the debugger so we can sort of see how we interact here. Actually, I don't need to set a breakpoint there, do I? I want to do that. And then I want to run this under the debugger again. Okay, here I am in my main method where I create my phone bill REST client. This is where I call client.getAllDictionary entries. I'm going to dive into that. Here I am there. I need a breakpoint there. I'm going to call the get method. We'll call it here. That goes off. Now we hit the breakpoint on the server side. That's nice. I'm just going to skip it forward here. And now when we go back to our project 4 session, we were here. Now we have a response. Let's take a look at what the response object is. The response object has a code, content, and also the number of lines of content that helps us parse everything. So HTTP code 200 was returned, which is okay. That's nice. And we're not really using it for, well, actually, we probably do use it for something, and we'll take a look at it in a moment. But we get this information back from the response, and then you can do things with it. So if we call get content, well, as you can see, content is all of the stuff that was written to the print writer by the servlet. And now it parses it. And so you can imagine what you can do, how you can do that, or maybe you might imagine how you can leverage that in your own classes. So now that basically then converts this information in the content off to a map. I won't go into the details there, but now this dictionary is a map of key value pairs with Doe and Ray. Okay, so that's how that method works. I want to debug it one more time, and we will dive into the guts of that get method. It actually does the URL get. This is for information only. You can just use the get method. The first thing we do is we make a check to make sure the parameters have an even number. In this case, it's 0, so it'll be fine. And now what we need to do is we need to put together the query string. Because what we want to do, well, in this case, we won't have anything in the parameters. The query will be empty because all we're doing is hitting the raw URL. And so now we create a URL object. We can look at this in the debugger. The URL string and the URL object is just hitting localhost 8080 phone bill calls. So here again, it's the same URL that we hit in the web browser, right? Underneath the covers, basically, this Java program is doing exactly the same thing that a web browser does, which is like take a URL and do an HTTP GET on it. And so the way you do this is you use the standard, this is like a JavaNet HTTP URL connection class. To go out, open a connection there. We're saying, hey, we're doing a GET here. You gotta say input and output true. And then create a new response object, which will go through and, let's see here, initializes itself. That's super sweet. Oh, now it's hitting it on the back end. I'll continue there. I'll go back to my other debugging session. So that makes the request, gets the response code, gets the content, or reads the content. This is through all the lines. Not very interesting. Sets the content that was returned by the request, and then returns that response object, and now you can deal with it. So all that code that I just skipped through, that's stuff that you don't need to worry about. That's the magic that I provide for you, how to use the URL. And so what you really need to deal with is the stuff that's here, like in this REST client class, to be able to use methods like get, and there's also a method called post. Yeah, post to my URL. Okay. Oh, that's just a helper class, a helper method. To post data there also. In blank stares probably means it's time for a break. But any questions before that? Okay, I'm going kind of fast, and that's okay if things are going by. A big part of this assignment is to really get your bearings with the code, and I recommend that you go through exercises like this first to understand how to debug before we start making lots of changes. So let's take say another 10, and so let's come back at 7:55, and then I think we'll sort of do the last thing, which is how to write integration tests for this. So take 10 minutes. Stop all your debugging sessions, and stop the video.